Ah, non l'avevo visto. Sì, l'ho già testato comunque, va bene.
Bene, puoi anche staccare adesso, vuoi caricare.
Ah, perfetto. Ok, Anna. Ciao Raffaele. Hi everyone.
Hi Massimo.
Hey. Hi Renzo.
Hi, Massimo.
Hello. Hi everyone. There's still some attendees trying to join. Okay, we are 17. In the meantime, we wait for other people. If you want, you can switch on your camera, your microphone. We can. Hello, hello, Valentino.
Hello, Maestro.
Still someone? Okay, I think we can start in a couple of minutes. In the meantime, as you probably know, this is not a standard webinar. This is the first attempt to do a roundtable. So I hope you came prepared with some questions, either about the CKO or OpenSeas. If you don't have a question, then I prepared something based on the latest questions on our forum.
Hi, Dr. Massimo.
Hi, Lynn.
I think I have some questions about like changed parameters efficiently about one of the model recently I'm building, and it's a huge model, and change the first floor's Young's modulus or like the rate damping, something like that. If you can help me with that, I can be very thankful to you. Yeah.
Of course, that can be one of the, well, we can start with that. I think we can wait another couple of minutes for new attendees, and then we can start. Okay. I've seen also that you posted a question on how to calibrate the material parameters for the damaged TC3D.
Yeah. So actually,
so if you want, we can start with that, which will take a couple of minutes, and then we move to the parameter stuff.
Okay, sure, of course. Thank you very much.
Massimo, I have also a kind of general question about what is the situation with the validation you were doing on soil structure interaction modeling? Because I remember that the wavelet works very well, but I don't know if you've done any check and validation for real ground motions. I am a bit behind on that.
I mean, as it works for the Ricker wavelet, it works also for the standard ground motion. The reason why I use the Ricker wavelet is just for benchmarking purposes. The reason is that you can see, since you have just a pulse, okay, you can see the wave entering, then you don't have anything else entering the system, and you can see the wave that goes back. In a real life ground motion, the problem is that you always have some waves going in, okay? So it's pretty difficult to understand if everything is working. But of course, it will work. It's just for using a simple pulse is useful for benchmarking purposes. But of course, we've used it with any other kind of real-life ground motion. And it works, yes.
Thank you.
And we have also another question on the chat, how to introduce groundwater for liquefaction condition. Then we will talk about it also. We still have someone entering. And Valentina, I also started with the script for the section cuts.
Okay, thank you.
So probably if we have time, I can introduce it today.
Okay.
I still need to complete it.
Okay, thank you.
Okay, so I think we can start. Okay, so let's start this first roundtable. So Lin San already told me a couple of things, so we can start directly with first with how to calibrate the material parameters. So if you want to introduce your problem to the other attendees, Lin, about the material parameters, I mean.
Yes, so basically say I have a model, but like because we are doing some like filament updating, so we want to change some of the parameters we are interested in, like at each time step. So we want to calibrate those parameters through but right now the problem is that say the element at the first floor, based on the TCL file, we only have the the element number, but we are not sure. Like as for me, I don't know like for that element belongs to the first floor. So it's for me, I don't know how to calibrate like say first floor's Young's modulus for all the elements.
Yeah. Okay, we can start with that. So let me share my screen. Can you all see my screen?
Yeah.
Okay. Yeah, here I noted out some of the questions. Well, this one actually we can answer first. This one, which is very easy. So here always Lin Sang was asking how to calibrate damage TC 3D. If you go on the forum, because basically I will explain it very briefly. So he was doing, he was testing different ways for modeling a shear wall, either with a simplified beam element or with a shell, with shell elements. Now the difference is that when he did the model with the beam elements, he used concrete O2. Okay. Now when he has to do the same model but with 3D elements, with shell elements, he needs an ND material, a multi-axial material. So he was wondering how to calibrate a damage TC 3D model that matches these parameters here. Actually, this is very easy. So we can start with that and then we move to the parameter stuff, okay? So everything, you can do everything just by, okay, just by using material tester, okay? So let's start with the concrete concrete O2. Okay, so let me see what are the parameters you were trying to use. So minus 49.6, and then you have 0.003. Okay, now I will simplify it. FPCU minus 42.16, so it's pretty flat. Minus 0.05. And then we have a lambda of 0.25. And an FT equal to 2.1. And an ST of 3160. Okay. So we can do some tests. For example, you can start by calibrating. Oh, we have another question here on the chat. Hi, Ping. Okay, then I will move to this question also. Okay. So the first thing that you can do is to visualize what it looks like if you don't know the shape of this kind of material model. You can start by looking at the material tester. So you can do a monotonic test in tension to understand how it works. Okay. So for example, we can try to push this one up to 0.001. Okay. So basically what you can see is that here you have your elastic response, then you have a peak at 2.1, which is exactly F2. And then the concrete O2 does not let you decide what is the shape of the softening branch. It is a linear softening, okay? And the slope of the linear softening is given by this one, okay? As a percentage, this one is actually, it is the Young modulus here is not negative, it's always taken as positive, but basically it's the slope of this part of the curve, okay? And then it goes to 0. Now with the damage TC 3D, this one can be actually, we can try to match this one as much as possible, but with the damage TC 3D, we have a real exponential softening, okay? So we can try to match it as much as possible, okay? So for example, we go to 0, almost at 0.008, okay? Now let's save this one, and let's try to do the same with the 3D model. Okay, so the first thing that you have to do is here is the elasticity. Now, in materials such as, for example, this one, you don't have the elastic modulus, because the elastic modulus, if you go into the description of the uniaxial material, the elastic modulus is taken from this value and this value here. Okay, for example, let's go to the material O2. And the Young modulus, I think it was, yeah, twice the FCP divided by the peak strain. Okay, so if we take a calculator, it was 49 twice 49.6 divided by 0.003. Okay, so the Young modulus is about 300. Okay, Okay. 33,000. So we can start by putting the young modules here. Yes. And then the Poisson ratio can be 0.2 like any other concrete. Then the FT. The FT is the ultimate strength in tension. So it's 2.1, exactly equal to the one that you have here. Okay, 2.1. Now, in the concrete O2, you can specify the slope of the unloading branch, of the softening branch. Here you can't. Here you can specify instead the area under the curve, okay? The area under the exponential curve. Now, actually, if you look here, where is it? We have 2.03, and the ultimate strain was 0.008. If we do the material tester here, so we can actually compute what is the what is this one, for example. Let's imagine it is like this. Now I will do it quite approximation, but it is fine. So it will be 2.1 times 0.0008 divided by 2, because it is a triangle, okay? So this one is the area underneath this triangle here. And this one can be the fracture energy in our case, okay? Now you have to remember, this one is the fracture energy, is the specific fracture energy, because you have the fracture energy in a stress strain curve, okay? And there is the topic of fracture energy regularization, okay? But now I don't want to talk about this because it will take a lot. So let's say we don't want to regularize anything, so we can put that number, which is, okay, 0.0084, okay. 2 or 3 zeros, 3 zeros. Okay, and then we have FCP was 46, I remember, 49.6. Then this one is actually in the concrete O2, the parabola starts from the very beginning, okay? In this model, you can start from 0, should be a number which should be higher than this, but we can start, for example, with something which is about half of this one, okay? So like 25 is fine. Then the residual strength. This one is exactly the value that you gave here, okay? This one is the ultimate strength, which is 42.16. Then the peak strain is exactly this value, so 0.003. And then here you need the fracture energy. Now we need to understand what is this fracture energy here. Then we will play with this value. So let's go back a little bit with the uniaxial material. And we can do a test in compression, so monotonic, but we can go in compression up to the ultimate strain or something more. For example, the ultimate strain is 0.05, we can do 0.6. Okay, so this is the behavior in compression. Okay, you have a parabola here up to the peak strain, then a softening, and then a residual branch here. We can try to simulate the same thing here in the 3D model. Okay, now I don't want to put the equation here for the GC, because actually we can test it directly with these parameters. Okay, so let's put a number like 0.1, and then we can try to calibrate it. We can keep everything as it is here. We can go to the implex. Okay, so let's first start with the monotonic test in compression. Okay, so this one is pretty similar to what we obtained. Okay, now of course, the other test was going down to 0 here, but because it was linear. Okay, so if we do a simple annotation here, it was linear up to down here. Okay, now in this case it is exponential, so it will reach 0 slightly forward, but it is pretty much the same. Okay, so in tension it is fine. Now let's test the compression. It was minus 0.06. And let's see if it has the same phase more or less. No, because of course we need to increase this fracture energy. Okay, now we can keep on increasing it until this value reaches 0.05. Okay, so let's increase it a little bit, like 0.03. Okay, you can see now that we have some more lower softening here. Let's increase a little bit more. Okay, now something that you can see is that the shape here is continuous, while in the concrete O2, it is discontinuous. It reaches a peak, then you have a linear softening, and then the plateau. Okay, now actually this can be simulated in the damage TC3D by changing these parameters. Okay, if we go to 0. Close to 1, but lower than 1, and here we go close to 1, but above 1, so like 1.01. We can do a test. And as you can see, this is pretty similar to the other. Okay, now it is discontinuous. It takes the peak here, then you have a linear softening, and then a plateau. And now we just have to increase it as far as this point reaches 0.5. So it can be like 1.2. Okay, something more, 3, something less, 2.5. Okay, 2.2, it should be fine. Okay, so you can use the material tester, and as you can see, you can simulate the same parameter. Okay, so it's pretty easy. You can take these parameters here to match your concrete O2. Okay, but the idea here is to try to understand what the parameters mean and try to use the material tester. This is very, very useful. Okay.
Okay. Yeah. Another question. So this meeting is recorded and will be uploaded, right?
Yeah, we are streaming on YouTube, so you will have the video also.
Okay, thank you very much. And also, I have a suggestion because there's a link, a damage TC3D, but when I click it, so I'm as a user, like I'm very confused about like C1, C2, C3. These parameters influence this shape. So if you can in the future have a more detailed description, it can be very helpful as a user like me never have experience over material this stuff.
Yeah, in fact, we are now trying to produce some more documentation on this kind of material. But yeah, the nice thing about the material tester is that if you are not sure about the meaning of a parameter, you can slightly change it and you can see how it affects the output. Okay, so that's why the material tester is very useful. Okay, you can test the material parameters before you use them in an analysis. Okay.
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 Thank you.
Okay, so now we can move to the parameter question. Let me see, we have something in the chat here. Yeah, groundwater fashion. Then I will move to these other questions. Okay, we'll explain also this one. Okay, this creating an interface for Grasshopper. Actually, well, I don't know if we are going to do that because actually it will be not so easy, and I don't know, it's not what we want to do actually, because Rhino is another software. But the point is that in our case, STKO is the respective of Rhino. Okay, so it's the modeler is STKO. That's why linking it with Grasshopper might not make sense in this case. Okay.
Yeah, thanks. Can you hear me, Massimo?
Sorry?
Can you hear me, Massimo? Yeah.
Can you hear you, Marco?
Yeah. So basically, I mean, I understand that Rhino is a sort of visualization software. So it's like what STKO can do. I was just more wondering about the possibility to generate parametric model. That is pretty handy and it's pretty easy for anyone. That's why I would be like super happy to use STKO in that case.
Maybe I can answer to that.
You really have a big know-how.
Because we also answer already, like, and I can answer to that. We are interested. We are not saying we are not interested. We are interested in parametric analysis. I think it's very interesting. But right now we have a lot of things we are developing a lot of new things like digital twin, artificial intelligence, a lot of new also future for the post processor. So we have 4 or 5 people just working on this, and our plate is too full. But if you want to, join us, we can think about it. Right now,
we should discuss. I mean, because I'm really impressed about the know-how that you have, and in some way, I mean, I don't know all the stuff that you know, but in some way, I proved that it's possible to implement OpenCs in Grasshopper, and I mean, I think you would be like amazing if you can in some way do it.
We believe is interesting, but as I said, like we need to give priorities, and now when you have 5-6 people just working is, when we get out of the tunnel, we are going to also to look into this.
And the other thing is that basically what we are doing now is to create an interface, a Python interface between SDKO and the user, so that the user can create parametric models in SDKO using this Python interface. It's still at the beginning, there is still a lot of work to do, but this is actually the way we want to create parametric stuff inside SDKO. Because linking to Rhino is fine when you don't have a user interface. So you use Rhino as a user interface. Okay, but in our case, it's a little bit different. Okay, so the point of view is completely different. That's the point. Okay.
Okay, thanks.
Okay, so now we will move to the other question of Lin San. So Lin San, the question was about the material parameters, okay?
Yeah.
Now the point is that you don't know how to change the material parameter to a certain finite element, right?
Yes, like say I want to change like the first floor's and all elements Young's modulus, something like that.
Okay.
Or like
maybe Lin, you can show the model so we can we can help you directly with the.
Okay. Yeah. So I cannot share the screen right now. If you can help share the screen.
Oh, yeah. Yeah. Okay. Now.
Yeah. So can you see my screen? So basically, this is the model I'm building. It's complicated, like because I'm doing finite element updating. So say I want to change, the first floor, all these elements, shell elements, and the beam column elements. Young's modulus. Do you have any way to do this? Also, I don't want to use the STKL because I'm using the supercomputer, which they don't have STKL there. They only have OpenCs. So if you can find a easier way to do this, it can be very helpful for me.
Yeah, I mean, updating a parameter, it's actually a functionality inside OpenCs, okay? So you can use STKO to access the set parameter command, and I will show you how you can do it, okay? Now, we will do it in a very, in a small model now, of course, not on this one, otherwise it will take a little bit. But before we go to that, I've seen that there is some question here about by Mr. Ping, probably. Yeah, Ping Zhang. Hi, Ping. You were asking if for STKO version 2, if we can import TCL file inside STKO. This example that actually what I want to say is that we don't have a built-in functionality to import the TCL file, but if you look at what Lin Sang has here is actually a script that we helped him to prepare, like to introduce, to read a TCL file. Okay, and actually what I want to say is that we don't have a built-in functionality to import. What is happening? I'm hearing my voice. What Lin Sang has here is actually a script that we have.
I think someone maybe has opened the YouTube.
Probably, yeah. What I want to say is that we don't have. Okay, now it's fine. My voice disappeared. Okay, so here Lin Sung has used the Python API inside STKO to import a TCL file. Okay, is it correct, Lin Sung? So basically, this model was created importing a TCL file. Okay, so it can be done. It's not a built-in functionality, but with the Python API, this is what we can do also. Okay.
Maybe we can add that, like we are thinking to release it in a couple of months maximum, the TCL importer.
And of course, it is a work in progress because importing everything, it's a huge job. So we are focusing on the main elements, okay? But of course, it's something that can be done, and we are working on it.
By the way, maybe we should introduce Ping, just 2 seconds, so
Ping,
you
if
can
you want. Ping?
No, you can introduce him.
Yeah, I just want to know if he's here.
Yes.
Hey, hi, Ping. So if you want to introduce yourself, and we can talk a little bit about this new project in China.
Oh.
But I mean, maybe like Ping is going to be working with us in China, and is going for us to be our technical support in China. We are very excited. We are starting now, and he's studying. He's a PhD student from Hong Kong. He's Chinese, and we are very happy to have him on board. You want to say something, Ping? It's 1 in the morning, so maybe fell asleep.
Probably. Probably. Of course. Well, okay, then I will move to these other questions. So let's go back to Lin Sang. I will share my screen now, okay?
Okay.
So now to update material parameters, there are actually several ways. Now I need to understand what you want to do, but actually I can show both things. Like, let me do a quick test, okay? So let me create in this folder, a new folder for checking the parameters. Update parameters. Okay, let's create a new file. Okay. And I will do this example for shell elements. As you can see, let's check in OpenSys if the shell element can, because the main problem with updating the parameter is that you need to make sure that the element that you have is able to set the parameter, okay? So for example, in your case, Lynn, you want to update the young modulus of each shell element of a certain floor. So first of all, you need to understand if the shell element you are using supports the updating of parameters. Otherwise, it's not possible.
Mm-hmm.
Then, for example, in this case, we have to check the shell element. In your case, the shell element is the ASD shell, right?
Yes.
Okay, so this is useful for everyone. Even if you're not an OpenSys developer, it's pretty easy to go inside the OpenSys source code and try to understand if that element supports the update of parameters. Now, for example, for a finite element, it is under this project element. Then you have shell somewhere here, shell. And then you have the AST shell. Now you need to open the C++ file, not the H file. The C++. Once you are here you can go under the name of the class, which is ASD shell. And you have to look for a method called set parameter, okay? The element has a set parameter. No, this is the set response. I need the set parameter. Okay, you can say, okay, the shell element has a set parameter, and it is actually asking this parameter to any shell, okay? So for example, if I ask the shell element to update the parameter E, which is the young modulus, the shell element will actually forward this query to every section, okay? So this is fine. This is telling us that the shell element supports the set parameter. Mm-hmm. Now in your shell element, you are using what kind of cross-section? The elastic membrane plate section?
I think, let me check. One second. I'm checking. Because the model is so big, so
if you're doing linear elastic analysis, I think you're using the elastic membrane plate section.
Yes, exactly.
Okay. So for example, in your case, now the shell is fine. So let's go to the cross section. The cross section is under material section, elastic membrane plate section.
Yeah.
Also here we go under the name of the class and we find whether there is a set parameter. There should be a set parameter somewhere. This is the elastic membrane plate section. Okay, so this one does not have it, but I made a modification. Let me see. I think I opened a wrong OpenSys. This one I think is the OpenSys from the IGA. Let me just, it's an old version of OpenSys. Let me open the latest one. Yeah, I was opening the wrong one. This one is the latest OpenSys because I remember that I made that change to the cross section to support it. So once again, material section. As you can see in that old version of OpenSys, the elastic membrane plate section didn't have any set parameter, so it was not available for that. But in this case, in the new version, we can find the set parameter. Yes. Yeah, I made this modification a few days ago, and now the new version that you can find on the OpenSys side, it has this update parameter. Okay, so we can update all these parameters. So we know that the elastic membrane plate section can update the Young modulus, the Poisson ratio, the height of the cross section, the mass density, and also this one is a new thing, which is the a stiffness modifier for the bending stiffness. Okay, so we know now that the shell element can update parameter, and our membrane plate section can update the Young modulus because it has it here. Okay, so perfect. We can also visualize it. Okay, so we can make sure that the Young modulus that we updated is actually the one that we want. Okay, so we have two options actually. We can put a load, update the material parameter, and see if the deformation changes. Okay, otherwise we can simply visualize in a result what is the Young modulus. Okay, so let's try. Let's do a test. I can create a couple of faces. So let's say this one is the first floor. I will not create a real model. I just want to create an example. Okay, so first floor, and then you can copy it so that I can show you how to select just a portion of your model. Okay. Mm-hmm. Okay, so this one is fine. Two surfaces. Actually, we don't need anything because I don't want to create an analysis. I just want to update a parameter, do a record, update the parameter, and do another record. Okay?
Yeah.
So physical.
Italiano. Ah, ecco, è una ditta di
section.
Pescara.
Hello? Can you hear us? Okay. Section, elastic membrane plate section, and we can start with a default parameter like 1000, 0.2. I don't know what is the size there, but let's say 10, 0, and 1. Okay, so this is fine. And we can assign the same section to both of the slabs. Okay, so inside the STKO, basically you gave the same cross section to all the slabs of your model. Okay, and then at a certain point you want to change the Young modulus only to the lower slab. Okay, so let's get just the finite element, which is shell, ASD shell, linear. Okay, let's select both of them and drag and drop the element property. Okay, then we need to assign boundary condition and so on, but it's not important now because I want to just show you how to update the parameter. So the first thing that I want is to create a recorder. As you can see, the elastic membrane plate section in this version, okay, and you can download it from Professor Tarke's website. In this version, you can visualize in the output also not only the stresses, fibers, response, and stuff, but also all the parameters that you can update, okay, in such a way that it is easier for you to visualize if the updating was done correctly. Okay, so in this case, I want to ask for E at every cross section. So in my case, so this one is the recorder, recorder command, and PCO results. I want displacement, and then I want a custom result. This is a shell. So I need a result for every section. So section point E. Okay, this is the name of the output that I want. Okay, perfect. Now let's do a first record. Okay, so if I add a custom command, so miscellaneous command, custom command, and then record, and then I do a domain change. Why? Because in this way I can separate different stages and I can show you how the parameter is changing. Okay, domain change will simply create another model stage. Okay, so I save this result and then I call a domain change. Now if I do this, now let me call it record. Okay, now let me mesh it. Mesh controls, faces, structure quad. Assign done. Global C, say 3, assign done. Will mesh. Okay, let's save it. And this one would be here. Roundtable. Okay, so now we can run the analysis and we can see the initial results. Okay. Okay, finished. Let's go to the output. And let's see what we have. Of course, zero displacement because we don't have any node, but we can visualize section E. Okay, so we have 3 to the power of 4 in both slabs, which is exactly the initial Young modulus that we wanted. Okay. Now the point is, how do I change this one in TCOL? Well, in OpenSys, you can use the concept of parameters to update these values. Okay, so let's go back to the preprocessor. Now you can do it in a couple of ways. In fact, if you go here under the analysis steps and under miscellaneous command, you can find parameter, set parameter, and update parameter. Okay, the 3 of them will work pretty much in the same way. Now, the update parameter is much easier if you want to change a parameter only once in your model. Okay, so imagine only at the beginning of your analysis you want to update the material parameter. You can use this one because it's much easier. Okay, and then I will show you the other option. Okay, the set parameter is telling you, okay, not the update parameter. The set parameter is the easiest one. Okay, the set parameter is telling you, okay, what do I want? First of all, you have to give me the selection set on which you want to update the parameter. Okay, so let's press cancel for a while. And you remember, you told me, I don't know what the elements are in my geometry. It's not a problem because you can create a selection set to say, okay, I want to apply this parameter only to this group of elements. Okay, so in my selection set, I want only this bottom face. Okay, right click and I call it bottom. Okay, now I have my selection set here. And let's try to update the parameter. So update, actually not update, set parameter, set para bottom to, let's say, 100. Okay, so I go under miscellaneous command, set parameter. What is the selection set? Selection set is all selection set whose elements are to be used for the parameter command. Okay, so in my case, I only have one selection set, which is the bottom slab. Okay, so this is the target. Then you have 2 different ways for updating the parameter. You have the constant mode or from table. Now, from table is something quite complicated that we use to assign random parameter in space. Okay, I'm not going to talk about this. There is also this possibility. Okay, we did it for another job, but in your case, you want to update it to a constant value. Okay, and you have to specify what is the parameter name that you want to update. Okay, now in your case is the Young modulus. Okay, and remember that the name should be taken from here. Now here, the elastic membrane split section supports one of these 5 commands. Okay, So in my case, it is E. So I write E here, and here should be the new values. Okay, the new value in my case would be 100. Okay, now I press OK. Now here I'm going to update the parameter. Now let me do a new record. Now imagine you did an analysis, then you update the parameter, and you do another analysis. Okay, clone, and let's see what happened now. Reload. As you can see here, now I have only one model stage, but when I reload it, I should have two model stages. Okay, first model stage and second model stage. When you go here, now it is changed. As you can see, I have 3 to the power of 4 at the top and 100 at the bottom. You see? So now I actually changed the material parameter down here. Okay, so this is one option, right? Is it fine, Linson? Is this what you want to do?
Yes, I think so.
Okay.
But I have another question. So
Lynn, I think also maybe it's better if we give also some space to someone else. Otherwise, maybe you can.
Yeah.
Otherwise, the others have a lot of questions and.
Okay.
The idea is that you can do it. Okay. So this one is a simple command to do it in a single shot. Okay. You can also do it programmatically. So you can also ask on the forum and we can talk about it. Okay. But the possibility to change the material parameter inside OpenSys is possible. Okay. And STKO has the interface to do it. Okay.
Okay.
So you can start it, and if you have any question, we can explain you in detail in the forum how to do it. Okay.
Yeah, of course. Yeah, I don't want to take too much time because I think some other people also have some questions.
I think we have some other questions. So let's go back to the beginning. I think, okay, how to introduce groundwater for liquefaction condition. Now, probably UA, you can help me here, but Pavan, yeah. When you talk about introducing groundwater for liquefaction condition, you mean the boundary condition on the pore water pressure? What do you mean?
Yeah, actually that's the same thing for pore water pressure.
Okay, so how you want to do that? Okay, now I'm not going to build an example, but it's very easy actually. You can go here. Now imagine this is a 2D model of a soil, and of course you did use, for example, a UP element, because of course when we are talking about the pore water pressure, it makes sense if you're using UP elements, so mixed elements with displacement and pressure, degree of freedom. Okay. Now imagine this one is a 2D model with a UP element. You can simply go under condition, okay, add. Fixing the pore water pressure is like fixing any other degree of freedom. Okay, so you need a single point constraint, right? You go under fix, and then you need to decide. Now, for example, imagine this one is a 2D model, so it is fine 2D here. You need to change the model type. It's not a simple displacement. It's not displacement and rotation, but it is displacement and pressure. So when you go here under displacement and pressure, you can click here and select the zones where you want the pressure to be 0, for example. Okay, so this is pretty easy. It's like fixing any other degree of freedom. Okay, is this what you were referring to, or do you need more information about this?
Yeah, actually I'm modeling a soil. Actually in that I'm giving an earthquake excitation, so that I need to have that liquefaction condition for piles, and I need to analyze it.
So I mean, fixing it to 0 is not sufficient for you. What you want to fix it to a finite value, or what?
Yeah, I need to fix it for a finite value.
So for a finite value which is not 0, you can use the SP constraint. But I don't know if the SP constraint in STKO has the support for the P value, because if it does not, actually you can do it by a Tickle script. Let me double check.
Okay.
Let me check, because it should be under load. UA, have you ever tried to use the SP for the UP? Oh, we have it. Okay. So SP.
Yeah,
prescribed nodal value is similar to the fixed value, okay, but it is a load. Also here, 2D, you go under, sorry, instead of displacement, you go under, oh, come on, I have a little bit of delay here. You go under U pressure, displacement pressure, and here you have the P, okay?
Yeah.
Check on the P, and you decide the value. For example, here it should be 1, and you assign it to the boundary that you want, okay? And that's it. The only point is that when you do this, you have to put it into a load pattern, okay?
Oh, okay, thank you.
It's like any other SP constraint. Okay,
Yeah.
well, okay, let's move to other questions. Okay, so water for liquefaction is fine. Then I also answered to Ping Zhang. Yes, we can import TCO files, but it is still a work in progress. We are going to present this new feature in a couple of months, and then we will work on it until it is complete. Okay, but it is possible. And it is somehow related to what Marco was saying, because actually we are using, to import the TCO file, we are using the Python API here. And the Python API can be actually used to customize and to parameterize the way you create the model inside STKO. So instead of doing it manually, you can do it programmatically. So they are kind of related questions. Okay, so here, Kashif was asking, I would like to know about the interaction problem. I'm trying to model the interaction of non-structural components with the structure, which turns out to be the case of non-classical damping problem. Could you elaborate whether we can handle it using STKO? So can you switch on your microphone or your camera so you can talk about a little bit about this problem?
Yes, thank you so much. Basically, my problem is like dealing with the non-structural component, more specifically like the cabinets within a structure at a different floor level, and more specifically in timber structure. So the problem is when I want to model this problem in any platform like Abacus, SAP, or anyone. So the problem is like the complex eigenvalue problem. Like if I consider the damping of the non-structural component and the damping of the structure, so it's different from one another. So the problems turns out to be the non-classical damping effect first. The second one is like the connection problem, like how to connect the non-structural component to the floor. So usually the engineers or the researcher, they usually consider the fix, or they use the flow response spectrum method. So we don't want to use the flow response spectrum method. We want a coupled analysis in which the non-structural component will be coupled to the building using the anchor or screws, right? So this is the complex problem. So I was looking for the interaction problem using STKO, whether we can handle it or not.
Yes, I mean, in the way you want to model it, it can be done, because actually, if I understood correctly, you want to model the non-structural component physically inside your structural model, and you want to create a between them, which is not a simple equal degree of freedom. It's something like a contact, a frictional contact, or nonlinear springs, right?
That's right.
Of course, you can do it. It's like modeling, you know, you take your non-structural components, you put it inside your model, and you need some way to decide what is the interaction. It can be a simple kinematic constraint up to very complex contact conditions. Once you have that, and you can find it, because we created a webinar on interactions, okay, and also a webinar on contact. The latest webinar were on the soil foundation structure interaction, where we used contact. So you can check our latest webinar on contact elements to understand how to connect this non-structural component to structural components. As regarding the relay damping, if you want to assign different relay damping to different portions of your model, in OpenSys it is possible. Is this what you want to do after you have your model, right? You want to assign
That's right, exactly.
Okay. So in OpenSys, basically, when you do you have two ways of assigning Rayleigh damping, okay? So imagine this one is a structural component and this one is the non-structural component, okay? So you modeled both of them, you created the interaction between them. Now you have two options to introduce Rayleigh damping. So one is to create the Rayleigh damping for the entire model, okay? Which is simply under miscellaneous command Rayleigh, okay? Now in this way you have two options, either the manual option when you directly input the alpha and beta parameter, or you can use the automatic option when you input the two bound frequencies, the Rayleigh, the damping ratios, and we compute the Rayleigh damping parameters, but basically they are the same, okay? This kind of approach will apply the same Rayleigh damping to the entire model. Instead, if you want to assign different Rayleigh damping parameters, you can use the region command, okay? So first you need to create this two selection set. For example, in this case, I have the selection set at the bottom. Let's say this one is the selection set for structural components. And then you create another selection set for non-structural components, like this one. Okay. Now that you have two selection sets, you can create two regions, okay? And you can call them dump structural components. You go under miscellaneous command, region, okay? You select the selection set for this region, which is, for example, the structural components. It is a region of element, it's fine. And then you click on Rayleigh, okay? Because actually in OpenSys, you have this region command that is used both to create a region and optionally to assign Rayleigh damping only to that region, okay? Now, in your case, you actually want it for the Rayleigh damping. So you create the region, you specify that it is a region made of elements, not of nodes, okay? In your case should be a region of elements. And then you assign your alpha and beta parameters, okay? You do this for the first one, then you clone it. You change the name for non-structural components. You go under selection set, you select the other selection set, okay? And then you enter some other numbers, okay? Different from the previous. At this point, you have two different damping parameters for the two portions of your model, okay? Is this what you want to do?
Yeah, exactly. That's what I want.
Okay, so for the damping, there is no problem. It's very easy. Region command. Just remember that. Or you can do also something easier. Imagine you have your structure is very large. Okay, so instead of creating two region command, you can create a standard damping. Okay, for the entire model, like I did before. Rayleigh damping, which is the damping that you assign to the entire model. Then you create a region command only for a portion of your model whose damping parameters should be different. Okay, this is actually the same. Because in OpenSys, second command writes the first one. Okay, so you can do the first one for the entire model and then you change some portions. It's exactly the same thing. Okay.
I see.
And regarding the contact condition, I don't know if you have looked at the webinar we gave for contact, but let me try to remember what it was. If you go under ASDA Soft, then you go under products, training, e-learning courses. And you go under the Fast Learn webinars. This one is the webinar 24, implicit, explicit, applied examples, soil foundation interaction and reinforced concrete structures. Okay. Okay. Different ways to how to apply contact between 2D models, between two different 3D models, between a beam and a soil. So there is pretty much everything here. You can look at this webinar and you can download the input files. Okay. You can clicking on here, you can look at where is it? Well, somewhere here, 24. If you click here, you go on the YouTube video, and here you can download the files. Okay.
Okay.
So okay. Find the Rayleigh damping, you can solve your problems.
Yeah,
Okay.
so thank you. Why I was really curious, because the main thing is the state of the art for this problem, interaction problem. Usually the paper, most of the paper, they say that the available numerical tools, they cannot solve the complex eigenvalue problems, referring to the non-classical damping effect. So what they mean, like the non-structural component are usually high frequency and the structure is kind of low frequency. So when they interact with one another, so the building nonlinearity come to into the consideration. Also, the height of the structure where the non-structural component is located. So that I was a bit curious why the researcher said that the available FEM software, they cannot handle this problem. That's why I was.
So you're talking about complex eigenvalue problem.
Yes.
But actually, here you told that you want to physically model them, because if you model them, you're talking about a complex nonlinear problem. The eigenvalue problem is not your issue. You're not going to do an eigenvalue analysis on a nonlinear model. It's a little bit different. So
Exactly.
probably, yeah, if you want to do an eigenvalue analysis of a model with a structural and non-structural component who interacts with each other, I'm not experiencing this topic, but of course you cannot do a straightforward eigenvalue analysis using contact elements or any other nonlinear interaction. I was talking about a real nonlinear analysis, okay? Not
Okay.
Massimo, it was talking about no classical damping. So the meaning is, I think, Rayleigh damping is not feasible for this kind of problem because of the change of frequency of the interaction. So it changes to a very large period. So, it's very difficult to control it with non-classical damping. I think this was the meaning of the question.
Yeah, so I mean, if using Rayleigh damping on different components with different Rayleigh damping parameters, it's fine. You can do it with OpenSys. If Rayleigh damping is not fine at all, even if you split it with different Rayleigh damping parameters, I think in OpenSys you have other kind of damping, like the modal damping, okay? But it's not documented, so probably we will do a webinar on that later on. But the problem is that there is no documentation on that.
This could be a solution, like the modal damping, for sure.
Modal damping is a solution for that. You can do something like this. You can start by using Rayleigh damping with two different Rayleigh damping parameters for these two different portions to take into account that they are very different frequencies. If it works, it's fine. If not, you can write on the floor, try to understand how to use modal damping.
¿Cómo vieni tú?
Is it fine?
Yeah, okay, thank you so much. Thank you.
Let's see if we have other questions. We were here, okay. Now, Mohammed, is it possible to automate the process of model creation in SDKO? Yes. The model creation can be done with the Python API, okay? I don't think we gave a webinar exactly on how to create new geometries, but if you want to understand how the Python API works, Mohammed, if you want, you can share your camera, you can talk, okay? As I said, the new features from version 2.0 of SDKO is actually this one, is the Python API, where basically you can create your own stuff, okay? You can create things here that can allow you to automate the creation of the model inside SDKO. So it can be done. We started creating some webinars on how to use the Python API, but there is still a lot of work to do in the documentation of this Python API. But I would suggest you to have a look at the Python API introduction that we gave. I think it was around here. Introduction, yeah, you can look at the webinar 20, Introduction to SDKO versions 2 Python API, okay? And here we gave an introduction to how to use the Python API, what you can do with the Python API. And then I use this one to create parametric analysis in OpenSys. Probably in one of these two webinars, I also explained how to create geometric components. I think in the first webinar, let me see if I've been talking about how to create geometries. Sorry, but there is a lag here, which is very okay. Okay, let me see what it is. Yeah, here I was explained also how to create some pieces of geometry, I think. Let me see. Otherwise, you can look at this webinar. I think at the beginning I gave some examples on how to create geometries. For example, here, how to create the interactions between geometries. So if you look at this webinar, you will have the introduction to the Python API, at least to have an idea of what you can do, okay? Then when you have this topic clear, you can come back in the forum and ask questions, okay? Because I can understand that this is a quite new topic, okay? So is it fine, Mohamed? Is this what you meant?
Yeah. So the actually problem, like my intention is that I want to create a building, 2D or 3D, like framed building, which I want to automate, like using the number of bays, using the like some variable number of bays, variable this bay width, variable number of stories, variable height of column. Like I want these inputs, which creates a building for me. Then I can assign the material properties and other thing.
Yeah, of course. So with the Python API, you can do it. Of course, learning the Python API needs, first of all, you need some expertise with Python. Do you have expertise with Python?
No.
Okay, so the first thing that you need to do, if you want to do this in STKO, is to learn a little bit of Python, okay? Because actually it's the basic language that we use here to automate the creation of the model, okay? As you can see here, for example, it is Python. Then you need to look at the webinars on how we use Python to interact with the documentation, okay? So for example, here you can see that I can access the application, get the document, get all the analysis steps, do a loop inside all the analysis steps, look if some analysis steps is called damage, and then I do something, okay? So you can create new components. For example, here I was creating some automatic analysis steps based on some conditions. So you can do it, but you need a little bit of learning, okay? So first Python, and then you need to follow the webinars. As I said, 20 and let me see.
Suppose I have some model created in the STQ. Is it possible to export the TCL file? Because it might be getting TCL file in the background, right?
Yeah.
Like for example, I am creating some model of any building or any other structure using STQ. Is it possible to export it in the form of TCL file and then edit it there?
Which is actually what STKO does. For example, let's take this example here, okay? I saved it under this folder, okay? When you actually click on run analysis, STKO is actually creating the tickle file, okay, here, and then it runs this batch file. As you can see, you have the tickle files. So let me remove everything, for example, except from this one is the file that I created, okay? If you run the analysis, it will actually first call write input file and then run the analysis itself. In your case, for example, you just want to write the input file. Okay, so as you can see here, you don't have anything. Then I click on write input file. I want to write it here. Okay, now the input file is done. You can see done, input file correctly written. You are here, and then you have the input files. Okay, you have the main command is here. Okay, and then it sources all the others.
Yeah, yeah.
So you have the input file.
Yeah, got it. If I want to make some small change in these tickle files, let us say changing some one material, like material properties of one element, like can I do that and then import back in the STQ?
No, that's why I mean, you can import it back, but when we are going to release the importer. But the problem is that I don't think that is the real approach that you would like. For example, if you want to parameterize a material model for a material parameter, for example, if you look at webinar 21, we will do exactly that. In webinar 21, I was explaining how to use the Python API here to customize some of the parameters of my model, like the load or the time step of the material parameters, and run parametric analysis. Okay.
Yes.
So I think the idea is you have to watch webinar 20 and webinar 21. Okay, webinar 20 is a general introduction to the Python API and explains to you what you can do. For example, how to create a custom model from scripts, how to update some parameters, and so on. Webinar 21 is specific for parametric analysis. So it will show you how to, with a Python script, how to change some parameter and run an analysis with that parameter set, okay? So writing the TCL file, changing the TCL file manually is not the way to go, because if you do that, you cannot import it back inside STKO. Or you can in the future when we will release the TCL importer, but I don't think it's the way to go, okay? So I think for you, it's much easier if you learn a little bit of Python and then the Python API, because then you will have a lot of freedom with STKO.
Yeah, thank you.
Okay, you're welcome. What else? We are here. Pavan, how to model a pile with parameters like bending stiffness, base rotational stiffness, and yield bending moment. Actually, this is like, if understood correctly, this is just how to model a beam with those parameters. So in any case, you always need to create a bending stiffness. I don't understand about the base rotational stiffness. Can you, what do you mean by base rotational stiffness?
I think you might mean like to use a zero length with.
Yeah, probably I was thinking about the zero length. So saying that it is not completely fixed to the soil, but Pavan, are you there?
Hello. Yeah, I'm there. Actually, I have some paper like from the research gate. In that it has given pile properties like bending stiffness and base rotational stiffness. I couldn't understand. That's the reason why I have asked you if there is any way. Yeah.
Well, bending stiffness of the pile is basically given by, well, you have to decide whether you want to model it as an elastic material or not.
Yeah, as elastic material.
Okay, if it is as an elastic material, you can simply go on there. Well, actually, then I will explain you what webinar you can look at. But imagine you have a beam model here. For the elastic part, you simply need to create the section elastic, okay? And here you can simply go under section to define the cross section that you want. You can either use one of the presets, like imagine in your case you want the circular section. Okay, so you can simply input the diameter and you can see the area parameters. Okay, and so the bending stiffness, of course, will be this one times the Young modulus that you put here. Okay, so this, for the elastic response is pretty easy. Then you told me about where is it? You told me about the base rotational stiffness. So I imagine that you're talking about the connection between the bottom of the pile and the soil. Is it right?
Yeah.
Okay.
Yeah.
So in that case, you need to create a zero length connection. Do you know how to create zero length elements in OpenSys and STKO?
Yeah.
With an interaction, you create a zero length. Well, in your case, when you have two, let's say, for example, in this case, you have, like, you create your pile, then somewhere here, then you assign the elastic section to your pile. Somewhere here, actually should be at the same position, but I draw it here just for simplicity. This one is a node of a soil element, okay? Or just a fixed node, it depends on what you want to do, okay? Now you can simply create an interaction a node-to-node interaction between this master node and this slave node. Okay, once you have the interaction, you can simply create materials, a uniaxial material for the rotational behavior. Okay, you can choose simple things like some standard material, uniaxial, other uniaxial material, and you can use something like the pinching for, well, whatever fits your the experimental results that you have on that paper. Okay, you set this up. Okay, and so basically you can have a kind of, I'm not going to change all the parameters, but you're going to have a behavior which is something like this. Okay, once you have this one, so this also defines the bending stiffness of your at the base, okay, which can be different from the elastic bending stiffness of the pile, and the yield moment. Okay, eventually you can have a little bit of hardening and a drop in the moment rotation curvature, in the moment rotation graph, and then a residual plateau. Okay, we gave some examples on this one. Once you have your uniaxial material, okay, you create it like this. You need to create the material property for the zero length. Okay, and then you go under special purpose, zero length material, zero length. Okay, now you have to understand, well, first of all, it should be, I don't know, if you're doing a 3D material, 3D, you need displacement and rotation. Now you need to understand what rotational component you need. Okay, so let's have a look. Press OK for the moment. Let's switch on the local axis, and you can see that this element, okay, has the global local axis now. So, for example, in your case, you want to check the rotation about, I don't know, about here, for example. Oops. Rotation like this. So it will be the rotation about this axis, which is the Z1. Okay, the blue is the Z1. The X is the Y, and the Y, the green here is the Y. Okay, so you have X, C, and Y in this case for the zero length. So you want the rotation about the Z axis. So it's the rotation about the sixth degree of freedom. So in your case, you go under the zero length element, you switch on this one, and you assign the rotational material model. Okay, and then you can assign the same thing or different material properties to the other degree of freedom. Okay. If you don't want to do that, you can simply then link all the other degree of freedom with an equal dot. Like you go in condition and you say, okay, about the z-axis, I have a material model. In the other degrees of freedom, I just need an equal dot. So you go under multi-point constraint, equal dot. It should be a 3D with displacement and rotation. And you fix everything but the rotation about the z-axis. You select this one, okay? And now basically you have a material model that gives you a behavior for the rotation about the z-axis and an equal dot for all the other degrees of freedom. Okay? Is it clear?
Yeah, thank you.
Okay, you're welcome. Okay, let's see other questions. We are here. Okay, then we have Aritra Bagchi. I have two questions, basically from geotechnical background. How to capture the force displacement behavior of zero length contact to the element? As new compiled version of OpenSys 3.3.0 doesn't record it. Oh, okay, we are going to check it. I'm not sure about that. Two, suppose we have embedded concrete foundation and we want to introduce node-to-node interface element between soil and concrete. Should we give different numbering to mesh nodes for the specific region, only if we create mesh manually? Okay, so Aritra, can you share your webcam, your microphone, so we can talk about it? Because it's not completely clear, the second question.
Hello, sir.
Okay, so I will first try to answer question number one, okay? So you are saying that zero length contact to the element does not record anything.
Yes. Basically, okay. After OpenSys 2.20, before that, we can record the things. But after when OpenSys 3.3.0 came, then it is when I'm giving the recording for the capturing the behavior, I'm not getting any behavior.
Okay,
for Europe contract.
Let's check it, because probably they changed something. So it should be under, I think it was UV element, beam, contact, 2D. You're using the Lagrange multiplier or the penalty one?
It's penalty only, based on penalty.
Based on penalty. So okay, beam 3D beam. Whenever you want to understand what kind of result this element supports, it's the same thing as I did before for the set parameter. You select the class here, and then you go under not set parameter, but set response. You have a set response. Okay, so the set response is here. So probably something changed, because you have set response. You can ask for force or forces, and it will give you a vector of 3 components. Friction force, friction forces, it will give you a vector also of 3 components.
Just excuse me, sir. I am telling that about zero length contact 2D. You were talking about beam contact 3D basically.
Oh, zero.
So it's
sorry. Yes. Okay. Let me go back to the chat. He said 0. What is it? Oh, zero length contact 2D. Sorry. So it's not this one. It's under zero length contact 2D. Same point here. So I go here, I select the class, and I look for a set parameter, set response, sorry. Set response. The set response is here. So we can ask for forces, stiffness, as if we have pressure. It should be a scalar, I think. It is a scalar. Then gap will give you the current gap. Otherwise, it falls back to the standard element response. And the get response is also fine, because if I ask for 1, it should give me the resisting forces. So this one is fine. If you ask for 2, you have the stiffness. Otherwise, you have the pressure. This should be the contact pressure, I imagine. Yes. Otherwise, you have the gap. So why are you saying that it does not give you anything? Because it looks
actually,
like...
yeah. Actually, when I'm giving the recording, because before gravity analysis we have to give the recorder. So I want to capture the force displacement behavior of a zero in conductivity. So after that, when I'm recording the things, it's giving 0, 0, 0. I mean, force also 0, like this also 0. But I follow this PP value basically. Means I follow this code, and they told that you have to write like element force command only, and strain command to capture the element response, right?
No, but that is fine for the standard zero length, not for the zero length contact 2D, because the standard zero length...
Yeah, standard zero, we can find that. Yes, you are right.
Yeah, but this is not the standard zero length, because the standard zero length is a collection of n materials, okay? That's why you have a material, 1 strain. It means I want the strain or the displacement or whatever it represents.
Okay.
Material in direction 1.
Okay.
But in this case, it's different. This one can only allow you for these 4 responses: forces, stiffness, pressure, and gap. So basically, for this element, if you want to know what is the displacement, you can ask for gap, okay? And it will give you the current gap. It can be 0 if it is in contact, or larger than 1 if it is opening. Same for pressure. If it is opening, this one will be 0. If it is in contact, this one will be different than 0.
Okay.
You can simply create a recorder element with the pressure or gap variable. Try this and let us know if it works. But it should work as it is written.
Yeah, actually, because in your webinar also you have shown that how to check the force frictional behavior basically for zero and contact 2D, and you have shown us that mainly the nonlinear, it captures the nonlinear behavior of a interface. You have shown also how much frictional force it will withstand before going to in a plateau region. You have told that in your one webinar.
Although well, you are saying that I made a webinar on this element here.
Yeah. It's element.
But are you sure? I think I was talking about the new element, the ASD zero length element. Are you talking about this webinar? Maybe. Are you talking about the webinar?
This implicit, I guess, that one only.
Okay, but I was not using the contact today. I was using or probably I was doing a comparison, maybe. But here I was using another element anyway. It's an element that we developed. It's not the zero length contact to T.
Okay.
Probably I made a comparison somewhere, but I was not talking about how to record things here. Actually what I was doing is to get the friction, the force displacement, the friction displacement.
Yes.
Using the reactions. Okay, but it's the same. So what I did actually was something like, let me annotate it. I think in the very first example, the very first example, I created a simple two-node element. Okay, so this one was fixed, and I was applying, I don't remember if an imposed force or displacement here. And inside here, I had a zero length element. And then I was doing a comparison between the zero length contact and the ASD contact implicit explicit. Yes. But basically what I did is that I created a monitor to monitor the displacement here, okay? But the displacement here, since this node is fixed, is also equal to the delta displacement of the contact, which is also equal to the gap, basically, okay? Because this one is always zero. And then I monitored the reaction force, which is actually equal to the friction force. But just because this is a very simple example, okay? So monitoring the displacement at the top and reaction at the base is actually equal to what's inside, okay? Of course, the reaction changing the sign. Instead, but that is actually a nodal response. So displacement on top versus the reactions times -1 at the bottom. Instead, you can actually, if you use the zero length contact 2D, you can actually use the element recorder for pressure and gap.
Okay.
You want the response directly here inside the element. Okay.
Hopefully it will record, I guess.
Okay, try to do it like this and let's see if it works, okay?
Okay, sir.
And then here you have a second question. Suppose we have embedded concrete foundation and we want to introduce node-to-node interface element between soil and concrete. Should we give different numbering of mesh nodes for the specific region, only if we create mesh manually? Okay, this is not clear to me. Can you explain?
Basically, in the STQO, when you are doing mesh, I mean, when you're giving the mesh, it can generate mesh automatically. But if you want to do manually, so when you are creating some interface between the soil and concrete, so there we have to give the different node tags to create the contact, or we have to give the same nodes to create the contacts.
Probably you mean, basically. Okay, let me see if I understand. Now let's imagine here you have the soil.
Yeah, in the middle, suppose one concrete column is there, and two side basically soil is there.
Okay, so imagine this side on the right is the concrete, okay, and this one is the soil on the left, okay.
Left and right there is a soil nodes.
Okay, so here you have a soil node.
Yes.
And here you have a concrete node, okay.
Yes.
For example, the soil node is node number 1, and the concrete node is node number 2. When you create the zero length, you can simply create a zero length in between these two nodes, okay?
Okay.
No problem, but you have to take care of something. The zero length element, in STQO, this is done automatically. If you're doing it manually, it's different, because if you're using for soil element a simple U element, so a simple displacement element, then you have 3 dots, okay? And this is fine. If you model the concrete beam with solid element, you still have 3 dots, okay? And this is still fine, so you can create a zero length that connects directly node 1 to node 2, okay?
Okay.
Now imagine that for some reason, for concrete, you use 3 dots, standard solid element. But for the soil, you use UP elements, so displacement and pressure. Here you have 4 dots, okay?
Okay.
Now creating a zero length between a 3 dot and a 4 dot node is not allowed.
Yes, yes.
What
It
you
should
need to do
be
is
same DF.
okay,
Yes.
so if you have this kind of issue, you have to create another node here. Of course, it should be at the same position of N1. You call it N3, for example. Now I drawn it slightly detached, but it should be on the same position. Then you create the zero length between N2 and N3, okay? N3 should be a 3 dot node. And then you create between N1 and N3, you need to create an equal dot, okay? So E dot N1, N3 in dot 1, 2, and 3. So basically you are connecting the 3 dots between the N3 and the N1, leaving the pressure dot separated, okay?
Okay.
So in this case, you need to create an auxiliary node.
Okay. Okay. Okay.
If you do it with STQ, STQ is able to do it manually, automatically. But if you do it manually, you have to create this extra node by yourself. Okay?
Okay. Okay, I understand.
Okay.
Yes, thank you. Thank you, Professor Massimo.
You're welcome.
Thank you.
Okay, let's go ahead, and we have Zishan Bab. Is there any way to include the TCOL code already developed for a particular member to the existing model in STKO? Like I have developed the model for measuring field, which takes into account the biaxial interaction. However, it is very difficult to draw this model in STKO directly. Lot of zero length elements. Moreover, I can't add it to the input file generated by STKO as SCD file will not get updated. Okay, Zishan, can you share your screen or microphone?
Yeah, hi Massimo.
Hi. Hi. Okay,
Actually,
yeah.
I have developed this code for masonry infill, which takes into account the biaxial interaction. But drawing it contains a lot of zero length elements. So drawing it manually in STQ is very difficult, as I have to develop it for each frame. Like if I have a 10-story building, that also 3D. So is it possible that I can add that TCL code to the already developed model in STQ? Like we have already one masonry infill code that you have developed, but that is in Python. So
if it is in Python, okay. So the point is that I understood you developed a new element, but it's not actually a new element in OpenSys. It's a collection of existing elements in OpenSys. Okay.
Yes.
The point is that you can add some elements, so you can customize what STQ is going to write just by using a custom command. Okay. Right. Not by if you generate a TCOL file. Change it, and then you have to issue, because the next time you generate the TCOL file, your changes are lost. Okay. So the other option instead for you would be to create a custom command. Okay. A custom command is a way to introduce a custom script inside STKO. Like let me see if I have STKO open here. Yeah. Like for example, in this model. Okay, if I, oops. Okay, let me get rid of this. Okay, if I write the input file of this one, let me show you what I mean. Oh, I have to mesh it. Okay. I write the input file, and let's look at what has been written, for example, in analysis steps. Okay, so this one is my analysis steps. As you can see, I first have the recorder, which is here. Then I have my first record script. Okay, then the set parameter and all this stuff. Okay, down to the end. This one is the region for the last damping. Okay. Now imagine you want to add something custom. Let's say, for example, in between the first relay damping and the second relay damping command. Okay, you want to add something custom here. Okay, so instead of changing manually this tickle file, you can actually go here, create a new custom command, like miscellaneous command, custom command, and here you can write whatever you want, but it should be in tickle, not in Python. Okay, because actually this piece of code will go inside the analysis steps. Like, for example, you want to just write puts hello world. Okay, now it is at the end. I move it up, and it will be in between the first damping and the second damping. Now I write the tickle file, and let's see how it is changed. Now you will see something appearing here. Okay. And now, as you can see, you have your tickle file, your tickle script, directly in between these two steps. Now, if you think about it, you will be able in this way to add new elements. Okay. Now, the only problem is that if you want to add a new element like this, it should be in tickle. It is very easy if this element is not connected to other elements in STKO. If it is, you still have some options, but it's quite complicated to explain now. But the idea, for example, would be, imagine you want to create zero length elements to the corners of these ones, okay? Something that you can do is to start creating some regions. Like, for example, you can create a first region with all the nodes, for example, all the first nodes of your connections. Let's say, I don't know how your element looks like actually, but imagine it's a two-node element. You can collect all these vertices, and let's call it base vertices. And then you do another selection set to these others here, okay? And you call them top vertices. Now that you have them, you can create regions like this. You can create a region for the base vertices. You can select the selection set that you created before, like base vertices. And you can say, okay, I want to create this region, but actually I want to write a list with, actually it is not elements, but nodes in this case. I want to create a list in tickle that contains the IDs of my nodes, okay, of the mesh nodes that are in OpenSys, like, and I want to call them base vertices, like this. I press OK. Now you will see that if I write the tickle file, at the end of this tickle file, I have this new command. This is a region, okay, region number 8, that collects node from 1 to 4. But also here I created a list in tickle that contains the IDs of the mesh. Now let's double check it. This one should be, if I switch on the node labels, it should be node 1, node 2, node 3, and node 4. And they are exactly the same nodes you have here. Okay, now we are running out of time, but I want to explain you how it works. Because if you have now this list here, you do the same for the other vertices, okay? For example, the top vertices, then you can add a custom tickle scripts that does a loop between the base vertices and the top vertices, and you can create connections between them, okay? It will be quite complicated, but if you are interested in doing that, you can write on the forum, and we can help you doing this. The other option instead is to create your custom element directly in STKO. That is the other option.
That will be developed in Python.
Yeah, that will be developed in Python. So if you are familiar in Python, probably it will be easier to create the new element directly in STKO.
Okay, thank you. My second question is regarding RC joint 3D material. Okay. There it is written that LX, LY should be in local coordinators. But at a particular joint, there are elements from each, like each element have its own local axis. So which local axis it is talking about?
Hold on, I don't think I understood. Can you, do you have a drawing of what you want to do?
No, in RC 3D joint material, there is LX, LY should be in local direction, local axis direction. So which local axis it is talking about? Because at a particular joint there are elements. Each element has its own local axis.
Okay. Yeah. Okay. Let me go back to the RC beam column joints. Local X direction is the local X direction given to the joint itself. What I'm assuming here is that the joint has always like a 90 degrees direction. Okay. Now the only problem is that if you have beams which are not at 90 degrees, okay.
Right.
But actually, I think we can change it because it is not necessary that the material are actually in a triad, but that is the typical approach, okay? Your problem is that your node is oriented in a different direction, or that your beams that converge to the node do not have a right angle?
No. Each element will have its own local axis. So at joint, which local axis it is talking about? Because there will be
the local axis is talking about is this one. For example, imagine this is a, okay, let me draw some kind of beam. Okay, we'll do it in 2D, but the concept is the same. So this is your structure, okay? If you switch on the local axis, you will see what is the local axis of this vertex. Now, the vertex, it's quite confusing because you cannot understand what is actually the local axis here, but you can isolate this selection. For example, for this vertex, you isolate it and you can see that this one is the local axis of my vertex, okay? If you want, you can assign a new local axis, like, I don't know, rectangular local axis, which is, for example, in this direction, okay? And then you select this vertex and you do a drag and drop. Now the direction is changed, okay? Now the idea is that this one is an automation that we made for regular buildings, okay? But when the building is not so regular, you need to create some local axis. The only limitation is that what we assume is that at a certain node, the beams and columns that converge to that node, they have a right angle, okay?
Right.
If not, it will be a problem. Then you need to do it manually. Or we need to extend this beam column joint, okay?
Oh.
Is it clear now?
Yes.
Okay.
I have actually one more question. Like Mohammed initially said that there should be option to change the input file generated by STQ, because like if I develop a 3D building up 9-10 story, and if I have to simply change the dimension of one column, I have to draw this model again from the scratch. So there should be some option to change.
Yeah, I mean, you mean to change the size of an element, to change the parameters? What do you mean?
Like anything, like I have developed a 10-story 3D RC frame building in STQ. Now, if I have to change the length of a particular column, okay, I have to develop the model again from scratch.
Well, yeah, but not again, actually, because if you think about, well, it really depends on what you need to do, okay? So the most flexible way is to learn the Python API, because in this way you can regenerate the model every time in a parametric way. Okay. If not, if you want to use the standard CAD environment, it's not necessary to start from the beginning. You really need to understand what you need to do. For example, imagine that you have something like this. Okay, like, I don't know. Let me do something like this one. And then I want to duplicate it. Copy. And okay, and then I join all of them. Okay, now this is a single wire. Now you assign the material properties and everything to this. Now you're saying, okay, let's say you want to scale the beam height of these two columns, okay?
Yes.
Well, something that you can do is, for example, to explode everything. You will maintain the selection. So imagine that you have properties assigned to those beams. The selection will be maintained, okay? So now, for example, you want to scale these two. Well, you can go here, scale 1D. You scale them of this particular factor, whatever it is. Oops, let me do it again. Scale 1D, right click, select the base, select the top, and then we go down a little bit. Okay, perfect. So this is my new height. I select all of them, I move them back, and then I perform once again the make wire. So it really depends on what you need to do, okay? You need to understand how the CAD model works, because if you understand it, you can do it pretty fast. Otherwise, if you want to create dozens or tens of changes, okay, probably it's better if you learn the Python API. But for a single change, you don't need to start from the very beginning, okay? You can start from your file and modify some pieces of the geometry, okay? But yes, in the future, we are going to improve more and more the Python API. Okay, is it fine? Zishan, can you hear me?
Thank you, sir. I got it. I got it.
Okay, I think it's fine. Let me see if there are other questions. Vefa, hi Vefa. Nonlinear deconvolution analysis in OpenSea is using equivalent nonlinear soil models. Also, do you have any plans to implement feature which automatically creates soil springs for a given soil profile in a frame spring based structure interaction model? It is very hard to do it manually for different pile elevations. Well, first of all, hi Vefa.
Hi, Massimo.
Actually, I've never done the convolution directly in OpenSea. I don't know if it is possible, but actually...
Wait, Massimo, like Jose just made it for us. Do you remember?
I don't remember if he made an interface with another software or directly inside.
No, directly in OpenSea.
Okay.
With a single column.
Yeah, with a single column. But I think, yeah, I don't remember how he did it, but actually it is a tool that we are going to integrate inside SDKO. It will be in Python, so it will be possible. It is not available now, but yes, it is possible. This one actually, so you're talking about soil structure interaction without modeling the soil. So you want to just model the springs.
Yes.
Actually, I don't have experience on how to compute this kind of springs directly from the material property of the soil, but we have this collaboration with this professor, Jose Abel, which is very experienced in geotechnical modeling. So actually I can ask him, because we are trying to integrate new features for geotechnical engineering. So I can ask him if this is something that we can do.
Okay.
It will be, do you think it's useful for practitioners, this kind of approach?
I didn't understand. Can you repeat it?
I mean, do you think that this kind of approach will be attractive for practitioners?
Yeah, we're actually using MidaScan to perform this kind of analysis, and it's hard to create the soil springs for the piles. And so I wanted to see it in the SDKO and SKU.
Okay, so yeah, basically the idea would be to create a Python script as an automation in SDKO, like as we create, for example, a new contact elements and this stuff. Instead of being a new OpenSys element, it can be an automation that creates automatically, given some parameters, all the set of springs.
Yes.
There are some questions in literature. We can look into it, like Gazetas and other authors give some indication. So it wouldn't be too difficult. So we need to look into it.
Thank you.
If you have already some equation that you know you're using, you can share them on the forum and we can start trying that.
Yeah, we have some references. I will share them soon.
You can open a post on the forum.
Yes, I was very busy. Still busy, actually.
But okay. I mean, it would be useful. We will definitely look into it.
Yes. Okay. Thank you very much.
Thank you.
Okay.
So there are no other questions. I just wanted to mention, Valentina, that I was working on. Hi, Valentina, are you there?
Yes, I'm here.
I was working on that. Then I will show you how it works, because basically Valentina asked me a feature that we are going to integrate inside SDKO. But for the moment, I'm creating a script for her, which is actually, let me give you just a preview. But of course, I need some more time to do it. But actually, for tomorrow, it will be ready.
Tomorrow morning at 8 in the morning is going to be ready. This is what he told me.
We'll see.
In fact, when I opened this one, I was actually on a folder called Valentina because I was working on that. Yeah, the idea of Valentina was to, always in the frame of modeling a wall, either with a beam or with a soil, it can be nice to have a section cut integrator. So for example, you have a beam modeled with shell elements, then you create a cut here, or a cut in the middle or at the bottom. And I'm creating a script to integrate all the element and forces along the cut to basically have this kind of integral. So let me show you what the script will do. Well, I can do it with this one.
For VEFA, just like Midas Gen, like what it does with the section cut with the force sum.
So for example, if Valentina chooses to create a cut here, for example, I will take all the nodes there. I will take all the elements on one of the two sides, okay? Then the script, Valentina, will allow you to give a local axis orientation, like this one will be the Y, for example, this one will be the Z, and this one will be the X, okay? And then I will take all the element forces at this node coming from the element at the bottom, okay? So for example, here you will have a force like this, force like this, okay, force like this, and then you will have also horizontal forces. Basically, what I do, and then I have a centroid here in the middle, okay? What I will do will be to compute, for example, the sum of all the vertical forces along the x-axis, it will be the m, okay? Then the sum of all the horizontal forces along the y-axis will be the shear in y. Same thing for z. Of course, this is a shell. There is not this one here. And then I will do also the integral of each one of these forces times the distance from the center to compute the bending moments and so on. So basically, this kind of tool will simply take the output of a shell or a solid element and will integrate everything to an equivalent beam element. Okay, so it will be easier for you to check internal forces of walls and stuff. Okay, it is quite ready. So for tomorrow, I will send you a preview. Okay.
Thank you, Massimo.
Also, UA is online, Massimo. So maybe you can tell him also when it's going to be ready, the pore pressure.
Oh yeah, also the pore pressure. We are working on it, and I think in the next week it will be there, and we will also set a new version of SDKO on design safe. Okay, as soon as we have actually what we need to do for that is to include a new calculation in SDKO, okay, which basically allows you to take a tensorial output, which is the stress tensor in your case, and isolate only some columns, okay? Once we have that feature, it will be very easy for you to take the stress output, isolate, for example, the third column for the stress in the third direction, and then you have a scalar output that you can combine. In your case, you have to do a ratio with the nodal output, which is the water pore pressure, okay? So we just need to do that. I think in a week, it will be also ready. And it will be available with version 2.0.6 of SDKO. Okay?
Hey, Massimo, thank you for, can you hear me?
Yeah, I can hear you.
Okay. Yeah, thank you for all your help on this. And it's just like there is some, I'm not sure it's a bug or something else, but like if we are using some soil material like PDNY or PINY, and when we use SSP brick UP or when we use SSP quadrant UP or SSP quadrant element, it looks like it can show the stress contour, but if I try to plot the Gauss point, then it doesn't show anything on the post-processing.
No, actually, it is a known problem. It's not about that. It's that because you asked for material dot stress, for example, right?
No, I didn't do that. I just manually add the constant stress and strength in the MPCO recorder, but it still shows that like it doesn't show anything. It can show the contour, but it didn't show the Gauss point.
Maybe can you show it to us? You wait now, so maybe
if you have it there, yeah, you can show it.
Yeah, I'm not in the office now, but yeah, maybe I can upload the file on forum. So
oh yeah.
Yeah.
You can upload the file on the forum and I will have a look, yes.
Yeah.
I probably did change something in the latest version, so I need to understand. Actually, if it is something that happened in the latest version, probably someone changed the code inside OpenSys. So I need to have a look.
Yeah, and other two questions is one is about the it's still a per watt pressure. So I know that because for the higher order element like 9-4 quadrat UP or the 28 quadrat UP, because of the midpoint didn't account for the per watt pressure. So when you plot the contour, it looks very weird. Like
yeah, it looks weird, but actually it's not that you have the water product, the water pressure only at the corner nodes, and in the middle you don't have anything. The point is that the element assumes that the node in the middle is actually a linear interpolation of what's going on the two sides. The problem is that in the way they implemented it, okay, they don't have the P degree of freedom at the central node. So for STQO, it's impossible to understand what is the value in there. Okay? So probably in the future, we will try to create a sort of interpolation, okay?
Okay, I see. Another one is like, I'm not sure if that's still correct or not. If I'm not correct, please correct me. Like in the recent version of OpenSys 3.3, I think they cancel out the comment of the MPCO recorder in OpenSys.
No, what they are changing now is that to use the MPCO recorder, you need to, because you are trying to compile your own version.
It's just like if we try to use the latest version in design safe, but it looks like they cancel out that.
Well, when you are compiling it, I need to explain you, because now if you want to use the MPCO recorder or the DRM, they both use the HDF5 library, okay? Now you need to switch on a preprocessor macro, okay, to tell OpenSys, to tell the compiler that you want both MPCO and DRM. And you need to tell the compiler where to find the HDF5 library. It's a little bit more complicated to compile OpenSys. So if you need assistance, you can contact us, okay? But in the automatic compiled version of OpenSys, actually there is not an automatic compiled version now. Version 3.4.0 is not yet executable. They are changing the way they compile OpenSys, so it will take a lot for that.
But also, Ellen asked us to implement also our version. Maybe in February we can do that in Design Safe. So they can.
Actually, what you are going to do in Design Safe is to download the source
our fork.
Our fork, where I already did the modification for including the MPCO recorder. Okay. So there is no.
Thank you.
You're welcome.
Thank you, Yue.
And well, thank you everyone for participating to this roundtable. If you enjoyed it, actually, we can organize other roundtable like this instead of proposing always some topic for the webinars. Okay, so thank you everyone, and see you in the next webinars.
Thank you very much.
Thank you. Bye-bye.
Everybody. Bye.
Thank you so much.
Thank you.